Moderator Colton Ching and the Complex Isolated Grids panel.
Okay, I see a lot of folks are still at Gavin Bade's coffee break. I see. So thank you everyone for being here, and aloha and good morning. We really appreciate the opportunity for this panel to present at this conference. I'd like for everyone to think about this panel as sort of being the second half to the panel that Sharon Suzuki led just before the break. In this panel, we're going to focus around how do you plan out an electric system, especially islanded complex systems like we have here in Hawaii. But rather than just having folks from Hawaii form a panel to talk about what we're doing here, we're kind of doing it with a little twist. We've assembled a panel here with folks who bring worldwide and national experience planning out electric systems. Some of the panelists here are actually the developers of some of the best practices around system and distribution planning that you've actually heard about yesterday. And we wanted to have them talk a little bit about their views on how you do planning for an electric system, including complex and isolated ones. And then ask them to kind of give their perspectives of how some of their views and some of their best practices relate to, or perhaps don't relate to, Hawaii. And we would be remiss in planning out this panel and having a thorough and complete discussion if we did not include the folks from KIUC to talk about what they're doing on the island of Kauai as well, because they're doing some pretty amazing things there. And I think by default, and in particular because your moderator comes from the Hawaiian Electric companies, I think by default we tend to think about utility planning for the Hawaiian Electric companies. Not that there's anything wrong with that, but I also wanted to include a Kauai perspective to do a comparison and contrast there as well. So we have a great panel here before us. I'll do a really quick introduction, and then I'll actually turn over the bulk of the discussion to the panelists themselves. So we have a wonderful opportunity this morning. To my immediate right is Elijah Pack. Elijah comes from Australia. I think you'll pick it up with his accent in a little bit. But he's the manager of national planning for the Australia Energy Market Operator. So think, or AEMO. And so think of AEMO as the ISO and market operator for the entire Australian continent. And for those of you who may not be too familiar with Australia's system, it really is an island system. It kind of defines what a complex, isolated grid is. And so we have the honor of having Elijah here in his role as a manager of the planning team to share what's been done in Australia. To Elijah's right is Paul DiMartini. Paul is the managing partner of Newport Consulting. Paul, his resume is really long. I won't go through all of it. But I'll summarize to say that Paul is playing a role in many of the discussions and in many of the developments on policies and on plans and strategies around integrated grid planning, distribution planning, and the numerous things that fall out around that, including grid modernization initiatives. And he does it at the state level in California. He's been involved here in Hawaii, but also in places like Minnesota and New York. These are states that you keep hearing about who are doing things in the distribution and integrated grid planning space. And so Paul will be bringing that perspective in. And then to Paul's right, the far end, and last but not least, is John Cox. John is the engineering manager for KIUC. John wanted me to make sure that I said that he's an electrical engineer I don't know if that's a good or bad thing, John, but being a mechanical engineer, I have my own perspective on that. But John has a role similar to what I do at Hawaiian Electric Company. He does the system planning, and does the modeling, a lot of the technical reviews and interconnection work, whether it comes to small distributed rooftop DER systems, as well as the large grid scale renewable systems, including the PV and storage systems that Kauai has made a lot of press for in the last couple of years. So I think between the three panelists here, we're going to be able to talk about things globally, nationally, and locally around grid planning. So enough of that for me as your moderator. I'm going to hand the microphone over to Elijah to begin the discussion on Australia.
Thanks, Colton. And aloha, good morning, and good day to everyone. So as Colton said, I work at the Australian Energy Market Operator, and my team is a group of power system engineers, and essentially our job is to coordinate efforts across our industry to redesign, re-engineer, and modernize the power system to accommodate the change ahead of our industry. And change is a funny thing. It's often very difficult to predict, but then obvious in hindsight. So when I started in power system planning, we were planning for increased demand, and we'd always planned for increased demand. As long as we had an energy industry, we had increasing demand. Even if there was a recession, it would only be a pause. And there was an influx in gas generation at the time. There was a boom in Australian gas, and we knew how to solve this problem. We would build generation to meet the demand, and we would build more network to connect the generation. It was a somewhat easier problem back then. And then over time, we saw a huge influx in investment in wind generation, and then solar generation. Now we're starting to see battery generation. And whenever we plan our future, we think that whatever's happening now is going to be the technology. And we're thinking, okay, gas is our future. That's how we'll move forward. That's how we'll lower emissions. And then, yeah, the technology costs for wind came down, and then solar, and now batteries. So it's a constant struggle to keep up with the technological advances and to sort of plan in the long term for our power system. So yeah, over the last few years, power system planning in Australia has really changed. We have had increasing energy costs, and that's for quite a number of reasons. Our gas costs went up, our coal costs went up. We built network for an increasing demand that never happened. And then at the same time, we've spent many, many billions on renewable energy, and our emissions weren't really dropping. And when they did, it wasn't by very much. And at the same time, we've had extreme weather and some really serious power system events. So I feel like from a power system planning perspective, we've maybe not been doing a great job over the last decade or so. In power system planning, we talk of trilemma, and a lot of you will have heard of this. It's trying to solve a problem that consumers want us to solve. So it's in terms of providing energy that's affordable, reliable, and sustainable. And generally, you can solve any two parts of that problem quite easily. You can build a sustainable grid that's really reliable, but it's not going to be affordable, at least not today. So I think the challenge ahead of us in this industry is to continue to try to solve that problem. So given that we had all these problems in our industry, our chief scientist, Dr. Alan Finkel, did a review of our future power system and decided that we needed to, that AEMO needed to do an integrated system plan. Now, this sort of system planning approach, it's in vogue internationally at the moment. It's quite exciting, and it requires us to essentially optimize investment across the supply chain from end to end. So this is thinking about investments behind the meter. That's battery storage in your house, rooftop solar, demand management, through to the distribution networks, the transmission networks, and anything on the supply side, different kinds of generation and storage. And think of this as one entire system that we're trying to design and solve, because in the past we've had monopolies for our network investments, and before that we had monopolies in generation as well. And it's quite natural to think if you need more supply, you build generation, or if you need more network, you build more network. But it's often that you can use other solutions to solve these problems. So yeah, we constructed this massive optimization and put a lot of engineering work in it to optimize and come up with a long-term plan in Australia. I won't be able to talk too much about exactly how we did that. You can find me later, or you can read some really long documents if you want to. But I will leave you with 3 insights from that approach and what we found. The first one is somewhat of an inconvenient truth for a clean energy summit, and it was that keeping our coal power stations around for as long as possible until they reach the end of their technical life was going to be part of a staged exit. And that's because right now 2/3 of Australia's energy is produced from coal, and it's going to take a lot of planning and a lot of work to move to a lower carbon future where we don't rely so much on coal. And yeah, running those power stations, many of which are quite a few decades old, until they get to the end of their technical life will allow us time to sort of replace it in a staged manner. The second insight relates to what happens when the coal closes. And really we found at the moment, and even more so in the future, when coal power stations need to retire, it's going to be cheapest to replace them through a portfolio of resources. Wind and solar will form the basis of our bulk energy production, but then that will need to be supported by energy storage, by network, demand management, DER, and even some gas-powered generation for backup. And hopefully that can be a fairly clean gas-powered generation. So the second insight is that when your generation is weather dependent, you really need to understand the weather. And I'm not a meteorologist, and I didn't know too much about weather. I'm still learning. But I hadn't heard of a wind drought or a solar drought. But if you come to rely in Australia on solar generation, I live in Queensland, the Sunshine State, and still we have cyclones from time to time off our coast, and we'll have many days in a row of really cloudy weather with relatively low solar generation. And in some states we have low winds at times and low wind production, or winds that are too high. So really understanding those 1 in 10 year events and understanding how you'll provide backup power is really important. Getting to sort of 90-95% renewable energy is about half the battle. That last chunk is going to be a whole other challenge. And the last thing I'll mention is about community engagement. And I think the experience on Molokai, if I've said it right, is really promising, and I'm sure there's lots of good examples going on at the moment. What we found, part of our problem and our optimization that we were trying to solve was around renewable energy zones. So this is a concept where we could build the grid to a new area where there's high quality resources, say wind and solar, and sort of spend network, put steel in the ground, and then connect generation. And that's an optimization between generation and network investment. But we need to figure out where to do it. And to start with, we hosted these big workshops with a lot of people who came in and understood what developers thought, what consumers thought, what regulatory bodies and others thought about where we should build generation and network. And just by sort of printing out these maps that had resource quality and drawing circles around the areas with the best resources, that just started the conversation. And then we published the maps and the candidate areas, and we had a lot of feedback. Some was good, some was bad, but it started the dialogue. And yeah, so we had farmers write to us. We had state governments, mayors, policymakers, all sorts of people come to us and tell us what was wrong or right about different zones. And now we're developing transmission in Victoria, and we go to meetings, local meetings in the areas, and some of the questions we get are, could you build more? Like, are you sure this is enough? So there are going to be, I appreciate that Australia is a very big place, and Hawaiian Islands are smaller, and you've got fewer options. But at least for us, finding those areas where communities wanted the economic growth and really engaging at the ground level and starting early with a lot of options, that was really valuable. And it's not a lesson that needs to be learned and said because it's almost obvious. But yeah, it's something that I think we should never forget. Mahalo.
Thank you, Elijah. Let's kind of bring the scope down a little bit and look at things from a national level. And I think Paul is a great speaker who can talk about what's happening nationally around grid planning.
Thank you, Colton, and thanks for the opportunity to share a few thoughts, and look forward to your questions later. So as Colton said, I'm involved in a number of activities across the United States through work that I do with the U.S. Department of Energy, and as part of that, I do work under their technical assistance to states. So for example, last year there were a couple of sessions that I worked with the New England Council of Public Utility Commissions, of which Commissioner Anthony was part of that, and her staff. And you know, New England or California or what's happening here, Minnesota and some of the other states that Colton touched on, there's been a real trend towards understanding the implication of a more diverse power system with the rise of customer adoption of distributed energy resources, not just solar PV on rooftops, but as you may be well aware, in a number of states, actually the uptake of distributed solar has been through community-based solar, which has come on in very large amounts onto the distribution system in relatively short order. So it's really changed what commissions are trying to understand with respect to the role that the distribution system is now providing in effect as a generation tie, as opposed to just a means by which energy at the centralized level is being distributed out to the customers out at the edge. So this transformation in terms of how the system is evolving to one where you have not just a centralized generation, but rather merging into more of a hybrid system where you have still very much large scale, but also almost as being forecast here in Hawaii in the future, 50% of the resources coming from the distribution system. And this is also echoed, for example, in California. You had Southern California Edison, I think it was in 2017, had a forecast that by the end of the next decade, they would have about 50% renewable distributed resources in terms of nameplate capacity on the as part of their mix to meet their needs. So how that gets incorporated into a system, as Elijah touched on and has been discussed earlier today, has really changed how you have to think about planning for this system. Not unlike what's happened here, there's been a renaissance in the U.S. In many states to revisit integrated resource planning that for many states that had gone through deregulation in the continental U.S. Had kind of gone away from, and they've come back to that. But at the same time, they realize that they need to rethink how distribution planning's been done. And some of you may be well aware of what's been going on in California with the distribution resources planning, as well as what's been going on in New York, as well on a similar path. But that has been mirrored also in other states. For example, Minnesota, that Colton touched on, the work that they did there to define an integrated distribution planning process, and then look to how that then intersects with the integrated resource planning has been a really interesting evolution. Right now, there's an effort that the National Association of Regulatory Utility Commissions with the National Association of State Energy Offices, so NARUC and NASIO, have started an effort called the Comprehensive Electricity Planning Initiative, of which I'm an advisor to. And that is looking at this question of how to integrate the resource planning with the distribution planning to really account for the fact that we're going to have this sort of hybrid system, and what are the methodologies and what are the changes that need to be put in place in terms of the processes, the roles and responsibilities. As you can imagine, unlike here, where you've got, because of restructuring back, 20 years ago, you have different entities playing different roles in the process. You may have an independent system operator that's providing the transmission planning, not unlike what Elijah's group does. You may have the state energy office providing a resource plan, not unlike what you heard from the California Energy Commission. And then you have the utilities providing the distribution and having resource adequacy requirements where they're providing resource forecasts and to meet the renewable portfolio standards. So all of these have to come into the mix. They also, in many cases, in most cases in the U.S., where it's not a vertically integrated utility, you have timing mismatches. So the distribution planning is on one cycle, you have transmission on another cycle, and you have resource planning on yet another cycle. And how these all line up so that you end up with an optimal outcome is quite a challenging thing to look at in terms of change management. The benefit here in Hawaii between the two utilities is that you don't have to solve that timing mismatch in the sense of different entities playing different roles. There's always the challenge of trying to figure out how these things marry up, obviously, particularly with the increasing uncertainty around the customer behavioral aspect in terms of how they're going to adopt, and as you heard on prior panels, the technological advances and how that might play out. I mean, it was touched on briefly but not really addressed, which is how do you forecast EV adoption, and what really are EVs when we think about it in the next decade? Is it autonomous vehicle? Is it ride share? Is it subscription service? Is it people sharing that vehicle through some of these mechanisms? So all these paradigms are in play, and so when you're doing these long-term forecasts, trying to sort through that and the degree of uncertainty is really quite challenging. As Elijah touched on, a lot of planning in the past has been more or less deterministic around understanding where load forecasts were going, largely based on socioeconomic factors and local development activity. These things are starting to break down with the various changes that we're seeing, and particularly with distributed resource. It's less deterministic, and now we're, as an industry, trying to understand how to factor in uncertainty into the mix. And you heard that a bit on the commissioner talk this morning, trying to understand obsolescence and all these other factors that have really come into play now as we try and look much further out, realizing how fast things can change. I know when I was involved at Southern California Edison 10 years ago, we were forecasting electric vehicles because the state had a big push to have a curve that looked like this at the end of 2020, 1 million vehicles by 2020. As you heard, we're going to be, the state's at about half that number. The forecast for solar PV adoption on rooftops looked like this. And the reality was they were just the opposite. Rooftop solar was like this through business innovation, leasing, for example, whereas the electric vehicle was a little slower to take off for a number of factors. So these sorts of changes really do factor in, not to mention that, just over 10 years ago, when some of the smart meter programs in the U.S. were going, and in California, nobody contemplated the smartphone phenomena that, when Apple introduced the iPhone in fall of 2007. Imagine, nobody could imagine what we think of today in terms of take for granted in terms of the functionality and how we can interact with all our devices. That was sort of a future vision that people thought were much further out, and that reality exists. Where we're going to be in 10 years is really hard to think, but that's part of the challenge in the planning process today, is really how to think about those uncertainties, how to think about developing plans to account for that, and to be able to evolve gracefully as we make this transition over the next decade or two. Thank you.
Thank you, Paul. I'm going to pause for a second. I completely forgot about one of my fundamental moderator duties. Just to remind everyone to use the message shift link. to submit any questions for the panelists. Please send them over and we'll go through them here. Thank you, Paul, for that. So now let's talk about Kauai, and we've invited John to talk a little bit about what's happening on the island with KIUC. You've done a couple of large grid-scale solar plus storage projects. What's next for Kauai? What are you folks looking ahead for your island in terms of getting to your renewable energy goals and other goals?
Thanks, Colton. Good morning, everybody. I'd like to start off just to give you guys an idea of the last couple projects that we've been doing on Kauai. This project just came online on December. This is out on the south side of Kauai. It was a partnership between KIUC and AES. It's a 20 megawatt PV project along with a 20 megawatt 5-hour battery. It sits on roughly 190 acres. KIUC built a substation to interconnect this project, and it also feeds distribution loads out of that substation. A project right before that, there we go, there's our Tesla project. So this one came online in 2017. This one is a little bit smaller. This was our first battery PV project here. This is a 13 megawatt PV and a 13 megawatt 4-hour battery on our system. You can't see from this picture, but it's located right next to our Kapaya power station, which I'll be talking about a little bit later. Going forward, so for 2019, we have another PV battery project, and this one's going to be located on the west side of the island on the Pacific Missile Range facility. It's a Navy base on the west side of the island. This project will be a 14 megawatt PV and a 14 megawatt 5-hour battery. This project is a little unique compared to the other two in terms of complex isolated grids. This project will have islanding capabilities. So the way we feed the Navy base right now is through a 69 kV radial transmission line. Every time that line goes out, whether it's a fault or any other kind of contingency, the whole base is out of power. So the Navy base, their load, peak load is in the neighborhood of 2 megawatts or so. So on this project here, what we're looking to do with AES is every time that transmission line goes down for whatever reason, we rely on the battery to take over the loads over on the Navy base. And you know, we're going to accomplish this on our last two projects. Both of those interconnections occur at the 69 kV level. For the PMRF project, the AES battery and PV is coming into a common 12 kV distribution bus that's also going to connect the base loads. So we have the capabilities for contingency loss, whereas if we lose the transmission line, but the base also has the option, when they go on critical operations, they can seamlessly cut over and run their critical operations isolated from KIUC grid. And then when they're done with their critical operations, we'll have the system synchronized back to our grid and allow excess PV or battery generation to come back onto our grid. So primarily these battery and PV projects, you know, we take the PV energy during the day, push it into the battery, and that allows our generation folks to dispatch it at night rather than turning on our conventional diesel generators. I'd like to talk about a little bit of the grid issues that we've been seeing with all this renewable coming onto the grid. KIC has been using batteries for around 7 years or so. And when batteries first came on for us, frequency response was king. So, anytime we had a frequency fluctuation, whatever batteries that we had on at the time, we would do frequency response. So it would basically stop the frequency decay and prevent a load shed. For example, if we lost the generator, the batteries would instantaneously kick in, arrest that frequency decay, and prevent the load shed. Nobody really knows that we tripped the machine. So as more and more projects started to come on, and in the meantime we were only using our battery systems for frequency response, we started noticing voltage issues on our system. So as more renewables come on, less KIUC machines are now online. Our traditional generators control voltage. Now, as less and less machines are on, that voltage control begins to get a little loose. So I know it's a little bit early to be talking about VARs here, but so we're now looking at our battery systems to do voltage response as well. So what happens when we say at midday, we're down to our last traditional generator, we lose that machine for whatever reason, we lose a transmission line or it's a unit trip, frequency will drop, the batteries will kick in, but then we start seeing a sag in our voltage, and that has led to cascading events where it can take off a grid scale PV going out on under voltage or something like that. So we need that voltage response from our battery systems as well. So that's what we're looking at doing with Tesla and AES. With that said, our power plant guys over at Kapaya Power Station, they just completed a project with their gas turbine over there that allows that machine to run in synchronous condense mode. So basically the generator is synchronized to the grid. It's not necessarily providing real power, but it's sitting there providing voltage support to the system. So when contingencies do occur, number one, we have the inertial response of that generator being synchronized to the grid, so it helps with our protection and short circuit current capabilities. But it also provides voltage support to basically stop any kind of voltage decay where we have cascading problems from there.
Well, so even large down to relatively small systems, a lot of these complex planning and operational issues really have some similarities because I think they have common roots. So my first question for the panel is sort of along that theme, right? So from your perspectives of the different electric systems that you've seen, that you've worked with, that you're familiar with, and have had a role in planning for, I'd like for you to kind of share your thoughts on how your perspectives on those systems that you work with compares to Hawaii's. We've heard quite a bit of that yesterday, but I'd really like to take this on directly, right? What are the similarities? Where do we see common issues? Where do we see differences, right? Whether it's because our grids are functionally different or because we're just in a different scale. I think sharing those thoughts would be very helpful to the discussion, and if you can kind of put that in the perspective of then how those differences will drive a need for perhaps differences in the way, or maybe opportunities for in the way we plan for our electric systems in the future. So whoever wants to take that one first.
I think that's one of those law professor questions where
Okay.
you went on and on a bit, but that's all right. I'll give it a go.
I'm not a lawyer.
So yeah, in Australia, we have a lot of coal. So for us, energy has historically been very cheap, whereas in Hawaii, I think all of the fossil fuels are imported. So that's quite a difference. But I think there's going to be a huge number of differences, obviously, between Hawaii and Australia. But there's also similarities. So even though those differences, it means that your energy might have been quite expensive to start with, and the relative cost of renewable is not such a leap. Historically, it hasn't been such a leap, and maybe it's become cheaper in recent years. Whereas, in Australia, we've almost needed policy to drive us towards lower emissions, because we've had such cheap resources, and for Australia, with such good coal, if we could develop a truly clean coal, that would be amazing for our industry. But the reality is not there today, and it might not come in the future. So I think what we need to focus on is renewable energy, and what we found was that there's a lot of confusion around the difference between the two. And I think I see a bit of a similarity in some of the discussions I've had. And we don't need to pretend that renewable energy is the same as conventional thermal or fossil fuel generation. So I think rather embrace the difference, embrace the fact that batteries can respond really quickly. There's so much differences. So what we did was we sort of wrote a document, the power system requirements, and sort of spelled out what we thought were the technical things that you needed to run a power system, and then point to different kinds of generation and transmission and devices like synchronous condensers and SVCs, and say which devices can provide these services. And that way we could all use a common language, we could describe things in the same manner, and have an open dialogue about what are the actual ways that we can provide these fundamental power system services.
Yeah, I think certainly one of the largest differences from the mainland is that the system planning takes into account diversity of resource, and whether that diversity of resources within that jurisdiction, say that state, and if there isn't sufficient diversity, there's a dependency on a regional basis to be able to diversify, achieve that level of diversity that's sought to maintain reliability and affordability by leveraging what may be developed in neighboring states through the interconnected transmission system. You don't have that opportunity. So that's a major difference is, thinking about supply diversity, supplier diversity, how that all plays out is quite different here than on the mainland, where you can depend on your neighbors and to some degree through regional planning efforts that happen beyond just what the utility or that state does. There's also these regional planning efforts, either through an ISO or RTO, or even in those areas where there isn't, say in the Western U.S., there's a collaboration that happens amongst the states and the utilities across those areas to do that. That's a pretty big difference. And to me, as has been talked about on a couple of panels today, as you start to push higher into the percentage of renewables that you're looking to get, I think one of the panelists earlier talked about you can get to 80% pretty easily, but that last bit starts to become quite challenging to get to. Elijah touched on that as well. In the mainland, they're doing that through regional diversity, and here I think the question is going to be, what are those technologies? Are there technological breakthroughs that are going to come in the next 10 or 20 years that are really going to help get there? Is battery storage the only answer, or are there going to be other things that are going to come into play? Certainly the creativity is talked about, dealing with stability of the system and using, say, power plants that are no longer operating all the time and using those as means to stiffen up the system to provide some of that stability. Maybe one, there are other technologies coming into play that are not batteries that also can provide some of that, and I think it'll be interesting to see. There was talk about lithium ion, and certainly that's the technology today, but if you look at academia and you look at the research labs around the world, there's a lot of people working on the next chemistries for battery storage that are less volatile, because obviously what we've seen in the mainland, and I don't know how much of an issue it's been here, but in some places like in New York, it's been a real issue with the local fire departments kind of putting up issues with respect to battery adoption through fire codes. For example, they don't allow batteries inside buildings, so they'd have to be outside. Well, that, in a space-constrained place like New York City, that gets to be quite challenging then to think about how that could play into the mix. So I think there's a number of things that will be coming that will be quite important. I think another piece that was on the Molokai panel that's a bit different here than I think in other places is the level of local community engagement on energy and climate issues is quite different than what you see in other places in the mainland. It's not that there aren't community interests, it's just that the level of participation and engagement and knowledge on the topics is significantly greater here, I've found, than in my work in other places in doing stakeholder engagement. And I think that's really to the credit of the state and the communities in being aware and understanding and contributing to that discussion.
And I think what's happening there is, especially in Australia and probably in the mainland, we've seen incremental change in our power sector for a long time. And over recent years, that change is really accelerating. And when you go to smaller places like Molokai, you really see that change is really obvious to everyone, and it really affects everyone. So yeah, when you're really taking a step change in the development of the power system, there really needs to be a step change in the level of consumer engagement.
Yeah, you don't have rideshare conversations in other parts of the U.S. about energy policy like you do here. So it's a real telltale.
Just to follow up on the diversity issue, KAC does have a lot of batteries, and we're putting on more, but we do recognize that we need to be diversified, and our CEO and our board of directors are here, and these guys are a pretty progressive bunch here, and for the last 5 or 6 years we've been pursuing a pumped hydro project, essentially using 25 megawatts of PV to pump water uphill and during the daytime, and as the solar day finishes and we start moving into our peak, we run that water downhill through a 20 megawatt hydro generator. So we're in the engineering phase of this project, and the work continues there.
Awesome, that's great. We're getting to the 3-minute mark, and I really wanted to make sure I can ask this question. Yesterday you heard the governor talked about experiencing 1 in 100 year, or I think he called it a 500-year event 5 times in the last couple of years. And it's sort of, that comment just sort of highlights the fact that as a state and as a community, we're experiencing things at a level and at a frequency that we really weren't expecting, nor for which our electric system was designed for. So as much as, and I'd like for you to put a Hawaii perspective on this, if you may, and think about Hawaii being so isolated from the rest of the world, and like any other modern economy, the incredible reliance we have on electricity to drive our day-to-day lives, and in case for electric vehicles, literally drive our day-to-day lives. How do you think about, or what are your suggestions on how we should be incorporating resilience and improving the resilience of the electrical system as we face some of these more frequent and greater challenges around climate change and other things, right? How do we do that at the same time march towards kind of countering the very things that are driving this climate change, right? By taking carbon out of our sector.
So I won't pretend that Australia has solved resilience, but we've certainly done a lot of work on the matter. And one of the things that we did was try to figure out what consumers want us to do, what consumers want us to spend. We did these willingness to pay, value of customer reliability surveys, going to thousands and thousands of people, asking how much would you pay to prevent an interruption that was 2 minutes in the summer or 2 hours in the winter, and we got all these statistics to try to figure out what do consumers want us to do? Because it's easy to change a planning standard and say we're going to be N-1 or N-1-1-1, or we need to just survive all these different contingencies. But do consumers actually understand that process, and can they get involved? Will they understand how much that will affect their bill and how much it will provide reliability and help them survive those events? So I think more than anything, it just comes back to understanding what are consumers willing to pay for additional resilience, and then comes the engineering to figure out what you can do and how far you can go within that budget.
I think one of the things that that I see happening around the country, including here, is this realization out of some of the more recent events that maybe we need to be thinking beyond sort of point solutions. I think coming out of some of the initial superstorms of the past decade, the initial thought was to deal with, say, critical facilities and have backup resources for those. But then in the more recent storms, I think we've realized that the number of critical facilities as enabling our lives and our economy to continue is actually much broader. I mean, things like an ATM becomes quite critical, in terms of getting cash and when those are out. So those sort of started to rise to the level of criticality. And it started to get a discussion, I think, more broadly about how do we holistically think about resilience within, enabling people's lives, in the various communities, and what are the type of solutions that we need to be thinking about. And I think this holistic thinking, which certainly here in Hawaii has started, I think is really at the forefront. I mean, obviously there's some, obviously terrible things that have happened in Puerto Rico, and they're still, addressing those needs. But we see this also in other places where, very devastating events. And I think there's also this sense of trying to understand that this 1 in 10 or 1 in 100 doesn't really, that's irrelevant anymore, because these things are happening consecutively. I mean, I live in Northern California, and obviously the wildfire, you thought, well, the Santa Rosa event, which is right next to where I live, how horrible that was, and how could that, possibly have happened again? And yet a year later we have the Paradise Fire, and, so many lives lost. So I think there's a realization that, these sort of thinking about expected value where, the probability of the event once and so often is kind of have to throw that out the window and kind of have a different sort of economic model to kind of think about, your question about, how much do you spend, but more importantly, trying to understand, I think, as the commissioners talked about, the societal impact as a whole, because of the role that electricity is playing, and increasingly so over time.
And I'll just add, it feels like whoever's making these statistics needs to sort of, fix their curves, because, it feels like all over the world, we're just not catching up to the fact that climate is changing.
Right.
And the old approaches to predicting these probabilities, might need to be updated. And we've been through similar things where we're slow to sort of fix our forecasts of PV uptake, and we increase it every year. But I think this is one of those ones where we need to figure out what's actually happening and where the trends are actually going.
John, you want to close this out?
Yeah, sure. It kind of seems like everybody's in a race here to 100%, but I think the key is, resiliency and reliability. So, on KIUC's grid, there's a lot of days where we're down to our last machine, and eventually that machine gets pushed offline, and we're just kind of sitting there, and the majority of interconnected systems are inverter-based, and we just, like I said, we're floating around there. So we need to meet our goals, but we also need to keep in mind reliability and resiliency, and that ultimately is cost.
Yeah. So great discussion. I think my big takeaway from this is that there's a lot that Hawaii can learn from Australia, from the rest of the U.S., probably from other places in the world as well. But I think some of the things that are happening in Kauai and happening on Maui, Hawaii Island, and Oahu, we're learning things that the rest of the industry can learn as well. So I think this continued collaboration and information sharing, I think, will benefit all of us. So Thank you guys so much for being a part of this panel. Really appreciate your insights. And with that, we'll end. Thank you.
Thank you.
Mahalo.